We have a couple of upstream, downstream problems. Now, using this question, I'm going to discuss a little bit basics of the upstream, downstream type of questions. The very simple understanding. So suppose you have a river and a boat is being rowed on it. So if the boat is moving along the current of the river. So for example, if the river is moving on the rightward direction and the boat is also moving rightwards. So what will happen? What will happen to the effective speed of the boat? So in these kind of questions, the important thing to understand is the effective speed of the boat. What do we mean by effective speed is the speed of the boat with relation to the nearby bank. So for example, if I have the river flowing with a speed of, let's say 2 kilometers per hour and the boat moving at the speed of 10 kilometers per hour, maybe that is the answer for this problem. But anyhow, so we have 10 plus 2 because the boat is moving in the rightward direction and the river will push it forward or in the rightward direction. That will be forward for the boat by another 2 kilometers per hour. So in each hour, the boat will move 12 kilometers. In the backward direction. So if I move the boat opposite to the current of the river, so if I have something like this. Now here the boat is moving against the current. So if the boat is moving against the current, in every hour it will try to move 10 kilometers, but the river will push it back by 2 kilometers. So effectively the boat will move 8 kilometers per hour. And I hope that you can see these numbers. So coincidentally, the examples I took, sorry for that, are the answer. But anyhow, we are going to solve this problem. Now coming to this terminology, upstream and downstream. Now it's very simple understanding. Stream always flows downwards, right? So if a boat or a ship or whatever is being rowed upstream or upwards the stream, so that has to be against the current, right? So upstream is always against the current and downstream is with the current. So upstream we will have an effectively difference of the speed and downstream will have effectively sum of the speeds. So for example, in this question, you don't have to take that scenario. You can actually solve this very simple problem. A man can row upstream at a speed of this much and downstream at a speed of this much. We are looking for the speed in still water and the speed of the stream. So the speed in still water, suppose the speed in still water is B, speed of the boat, let's say, and the speed of the stream is suppose R. Then when it is moving upstream, the boat will try to move B, but the river will push it back by R. So B minus R will be 8. And downstream, the boat will itself move by B and the river will help it to push forward by another R every hour. So that will be B plus R effective speed and that is 12. Simply add these two equations, you get 2B is equal to 20 or B is equal to 10 kilometers per hour and use either of them to figure out R as 2 kilometers per hour. So that is the answer for this particular question. Let's try another problem, a small variation here. So here we have a boat that can travel a certain distance downstream in 4 hours. It takes 6 hours to cover the same distance upstream. So now there's a small variation. The speeds are not known to us, but what is given to us is a certain distance, let's say D, the boat can travel upstream. First, okay, I just took the second one, but same thing. So upstream, it will take to cover this distance D 6 hours. And downstream, that is the first one, 4 hours. But to cover the same distance, right? So upstream, the time is 6 hours, downstream, the time is 4 hours. And the speed of the stream is given to us. We are looking for the speed of the boat. So let us assume the speed of the boat is B. So upstream with a speed of B minus 2, because the boat is moving against the stream, it travels D distance in 6 hours. So essentially this into B minus 2 should be D. Also in downstream, the boat is moving B and pushed forward 2 should be the effective speed. This into 4 hours should also be D. So if you just equate these two, you get something like 6 into B minus 2 is equal to 4 into B plus 2. Solve it whichever way you want. The easiest way, I say easiest because explicitly if you write this, maybe just solving this as an equation is the easiest way now. But just for a minute, I'm going to show you something. If you have solved a lot of problems of this type, we'll come to a scenario where you can write this directly without writing all of this. And here also you can see, you can just cross divide and stuff, and you get the same thing, right? So b plus 2 by b minus 2 is equal to 6 by 4. This can be figured out directly. So for example, you know that the distance is constant, so speed and time should be inversely proportional. So the b minus 2 should correspond to the 4 hours and the b plus 2 should correspond to 6 hours. Also, using common sense, you don't have to think that, because if b plus 2 and b minus 2 are the two speeds, b plus 2 has to be higher than b minus 2. So if the two numbers are 6 and 4, b plus 2 should correspond to 6 and b minus 2 should correspond to 4. You cannot have a negative b, right? So just by using common sense, you don't even have to think on inverse proportionality and stuff. But if you can write this, then you can also apply something which is known as componendo dividendo, if you are aware of it. So apply componendo dividendo on the left hand side, you should arrive at b by 2. And applying componendo dividendo on the right hand side, you can actually reduce this to begin with, but let us do it on this. So you will have 6 plus 4, that is 10 upon 6 minus 4, which is 2. So the 2 goes off, or b is equal to 10. So we have the boat speed as 10 km per hour. Or as I said, I mean, if you have done it in the basic manner, that is also fine, no issues there. So just solve this equation, you get 2b is equal to 20, 4 into 2 and 6 into 2 added. So b is equal to 10, same answer. So that's it for this particular video. I hope this idea was understood. Try some problems on upstream and downstream. There are very nice variations on these questions. We will also encounter some of them in our further videos. Thank you for joining in. If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.